We now want to look at multiplication of a vector by a scalar. A vector can be multiplied by a constant called a scalar. That is, k times vector A is equal to Ka, where k is a constant. K is called a scalar. Examples include a constant 3 times vector A, and that gives us 3A. A half times B, vector B, that is a half vector B. Negative 2 times 3 times C, that is negative 2C. We can have multiplication that involves two terms. For example, 2A times 3, and that is equal to 6A, and so on. We now want to look at vectors on a Cartesian plane. Vectors can be represented on a Cartesian plane in terms of the displacements along the x and y axis, written in column form, xy, called column vector. For example, in the first diagram, diagram A, we have AB, vector AB, and vector AB, there's a displacement from A parallel to the y-axis, 1 unit, 2 units. So this is 1 unit, 2 units along x-axis. So displacement parallel to x-axis is equal to 2. Similarly, displacement parallel to y-axis is equal to, that is 1, 2. So 2 units. So therefore, vector AB in this case is equal to two. In the second case, we have vector PQ. PQ, the direction is from P downwards to Q. So we move 2 units parallel to y-axis downwards and 2 units parallel to x-axis towards the left. Note the direction, that in the first case the direction was towards the right and upwards. While in the second case, the direction is downwards towards the left. So in this case, vector PQ is equal to -2, -2. Negative because for the case of x, it is 2 units to the left, while in the case of y, it is 2 units downwards. This was 2 units to the right, and this was 2 units upwards. So when the direction is upwards, the value of x, the value of y is positive, while if direction is downwards, the value of y is negative. If the direction is towards the right, parallel to the x-axis, the value is positive. If the direction of displacement is towards the left, parallel to the x-axis, the value is negative. Let us look at position vectors.